Okay, again, a competitive exam, you're looking at the questions. There's 1, 2, 3, 4, 5 questions. You try and make a determination which question looks easiest to do. So scan it over. I realize it's nerve-wracking sometimes. You don't know which one's the easiest one to do. Sometimes you might think the shortest one is the easiest one to do. The longest one's the hardest one to do. Uh, I would just pick something that looks reasonable. I'm going to say number 1 looks reasonable to me. That says find a polynomial of smallest degree rational coefficients. Key word here is rational coefficients. So, I mean, one thing you could try to do is just simply say, oh, I think it's if x is a root or a 0, the polynomial would be x minus the root. And the root, unfortunately, is an irrational number. So that's trouble right away. Oops, sorry about that. I couldn't say that. I couldn't say that's a polynomial. Just couldn't do it. So I have to erase that and say that's not working out. Let me erase that. And let me try again. And I'm looking at that. I'm gonna rationalize it. And this is something you've done in the past. I can multiply the bottom by its conjugate. And if you multiply the bottom by root 3 plus 2, you multiply the top by that as well. Now, what's nice about the bottom's really simple. What do you get? You get 3 minus 2, which is 1. Now, let's do the top. You would get 3 plus root 6 plus root 6 plus 2. And that gives you 5 plus 2 root 6. So now x equals 5 plus 2 root 6. Well, again, I'm in the same situation. If I were to write down, the polynomial, I'd write this down, x minus the root, which would be minus 5 minus 2 root 6. Well, let's try this. Let's try its conjugate, right? I'll get rid of the root, right? So it'll be 5 minus 2 root 6. So I'm going to say that's one root, that's another root. All right, let's write that down. And the other root, it's going to be x minus 5 plus 2 root 6. All right, so let's take a look. And I'm going to multiply it out now, and I'll be very careful. So x times x squared. By the way, I'm expecting to get a polynomial of least degree. Degree 1 wasn't working. I'm on a degree 2 polynomial where all the coefficients are going to be rational numbers, all right, ratio of integers. Let's take a look. So x times x squared. Then I get minus 5x. I'm distributing this x across the 3 terms. And then plus 2 root 6x. Now I'm going to do this. What do you get? Minus 5x. Let's see, minus 5 times minus 5 is plus 25, right? And then you're going to get minus 10 root 6. Let's do this. What do you get? Minus 2 root 6x. And then what do you get? You're going to get plus 10 root 6. And then last but not least, you get minus 4 times 6, which is 24. I'm going to add that together, and you get x squared minus 10x. These disappear. This gives me, let me just make sure I'm counting for everything. This gives me plus 1, and these disappear. So this is the polynomial of least degree that will do that. By the way, if you want to multiply by any rational number, you can, but that's probably the simplest one I could write down. Let's look at the answer key and see how we did. Okay. And I think they pretty much did the same technique, all right? By the way, I do write this up for a reason. For the students that need that to read through that, they can read through that. Again, the answer is x squared minus 10x plus 1. Okay? I'm going to get my eraser out. And again, I want to remind students that this doesn't disappear as a video. You can always pause the tape and copy things down if you want. I'm going to get problem number 2 now. And number 2 shows that the areas indicated in the graphs. Well, I'm going to call this area 1. And I see the labels. You need to know calculus over here. And it seems to appear to be an integration from 1 to root 3. I'm reading the title. I'm reading this. And the integrand is this over here, which is 1 over 1 plus x squared dx. I can do that integration. What do you get? You get arctan of x, and evaluate that from 1 to root 3. Well, let's see if we can get that area. What are you going to get? Arctan root 3 minus arctan 1. Well, let's take a look at that. What's the arctan of root 3? That's going to be 60 degrees, right? And 60 degrees is going to be what? Pi over 3 minus the arctan of 1, which is pi over 4. And what do you get? Common out of 12. And you would get 4 pi minus 3 pi, which is 1 pi. So that's the area of this thing. This is the area of this region over here. Okay? Let's do the next one. And I'm trying to show that area is the same thing. It looks like a far more difficult one, but I'll write it down for you. And it looks like it's, again, I'm looking at this over here. That's 1 over root 2 up to 1. And the integrand for this one is much more complicated. It's 1 over x, and then you get the root. It's going to be a really tough integration, I think. We always say if it looks tough, just try something. And I'm going to try to make a substitution. I'm going to say u is equal to, let's write this down, this over here, which is 4x squared minus 1. And du, I want to point out some students benefit by writing it down this way instead. That would be 1/2 4x squared minus 1 to the minus 1/2 times 8x. Well, and that dx, right? Let's see if we can figure that out, right? This doesn't look too promising, does it? But don't despair. You're just working forward. And this looks like what? Well, it looks like 4x over the root of 4x squared minus 1 dx. Well, I got to be honest, I do have some promising information over here, but I do have trouble. And I want to tell you what trouble I have. I really don't have what I want. And I'll tell you what I want. I'm seeing something like this. Let me point out what I mean by that. I'm seeing something like this, but I want an x here. So I'm gonna try to put that in. And if I did that, this would be x, and this would be x squared now, right? So now I think I see something here, at least. I'm seeing that part, right? But then I'm seeing something else that I don't want. I don't want this thing, but I'm seeing it here, right? Let me tell you what I'm talking about. So I'm going to say u squared is equal to 4x squared minus 1, or u squared plus 1 is equal to 4x squared. All right, so I know what this is, and I know what this is. All right, so I'm going to go over here, and I'm going to, try to do this for you. And I got this part, right? Let's write this integration down now. So dx, and then I got the x, 4x squared minus 1, right? Well, that's going to be du over 4x squared. But I don't want the 4x squared. What do I want? I want u squared plus 1. So I can get my eraser out, and I'll erase this over here. And this is u squared plus 1. All right, now I got to do the limits of integration. And I want to do 1 first because it's easiest for me to do, and that's the x. So my question is, what's the u? I'm looking at this over here. And the u would be what? It would be 4 minus 1, which is 3, so it's root 3. And if I do the lower limit, and I square that, would be a half, and 4 times a half is 2, and 2 minus 1 is 1, so the lower limit's going to be 1. And lo and behold, it's really the same integration, isn't it? What do I get? I get arctan of u evaluate from 1 to root 3. And we just did that. If you recall, this is what we did up here. So what's the answer over here? It's going to be the same. It's going to be pi over 12. All right, let's look at the answer, K, and see how we did. All right, they did the integrations, and they got the areas, and they showed the areas of both of those were the same area. All right? And that's important. You're able to do that. Okay? So let's go to the next one. And let me take, I did 1, right? And I just did 2. And now I'm going to go on, I'll do number 3. I need to make an erasure. Again, these are recorded videos, so you can always go back and look at it again, okay? I'm going to do this one over here. And this one looks really perplexing to me. And I want to see if I can do it. And I'm looking at it, and I realize it probably has something to do with integration, a calculus problem. So I'm going to try to get that. And I'm going to write this as f prime over f of x is equal to 1 over 1 plus x squared. Now, you may wonder why I've done that, because I think I can integrate both sides now. So I'll write this over here for you, and this would be f prime of x, f of x, dx equals 1 over 1 plus x squared dx. Well, the right side's pretty easy. We just did that, right? That's the arctangent. Again, if you don't know calculus, this would make no sense at all. I'm going to say some constant of integration. The right side also looks recognizable to me, but I want to point out it may not be recognized to everyone. So I'm going to say u is equal to f of x, and du would be equal to f prime x dx. So this integration over here, I'll put a little star on it, would look like, well, it would look like 1 over u du. So what's that integration going to give me? It's going to give me the natural log of the absolute value of f of x. Okay? Now here's another thing they told me. They told me this. I think I can do it. So I'll write this down. Natural log, the absolute value of f of 1. Now someone said, why are you doing this? I want to find out what that constant is. And you would get the arctan of 1 plus c. What's f of 1? It's root e, right? So it's going to be natural log. Well, the root of e is a positive number, so it's just going to be e to the 1/2. And then the arctan of 1 is pi over 4, right? Plus c. And this would be 1/2 equals pi over 4 plus c. And I think I now know what c is, right? What's c going to be equal to? 1/2 minus pi over 4. We haven't answered the question yet, but I certainly know something about this. And let me write this down. So the natural log of the absolute value of f of x is equal to, let's see, the arctangent of x plus c, which is 1/2 minus pi over 4. What do they want, though? They want to know what happens when you go towards infinity. All right? Let's see, as I go towards infinity, and by the way, of f of x, by the way, I hope you realize that this thing here goes to pi over 2. So as I go towards infinity, this is definitely a positive number, right? So I'm going to write this down now. So f of x is equal to e, which is a positive number, by the way, arctan x plus 1/2 minus pi over 4. And what do they want to do? They want to take the limit as x goes towards infinity. That's their question, by the way, and I'm ready to answer it, of f of x. Well, what's that going to be? Well, it's pretty simple, because it's going to be e. Now, I'm looking at this thing over here, And that guy's limit's going to be, when you go towards infinity, the arctangent would be getting closer to pi over 2 plus 1/2 minus pi over 4. Let's keep doing the arithmetic. And what do you have here? You would get e to the 1/2. Let's see, pi over 2 minus pi over 4 is going to be plus pi over 4. Okay, that's my answer. All right, let's take a look, see how we did. And that's number 4, right? Let's take a look, see how we did. It's tough though, isn't it? Yeah, got it right here. Pi over 4 plus 1/2. E to the pi over 4 plus 1/2. That looks pretty good. Okay, let's do 5. It says a curve defined parametrically by these equations over here. So, kind of looking at it, and let's take a look. It says determine the equation relating y and x. That means I got to eliminate the parameter. Well, let me write this down, okay? And we'll think more carefully about what we're saying in a second. This is 1 over t squared plus 1 times t, and y is equal to 1 over t squared plus 1. So x is equal to, let's see, 1 over t squared plus 1 is just y, right? So y times t. And this tells me that t is equal to x over y. All right, let's plug it in. I'll plug it in here. Let's write this down. X equals, well, t I said is x over y, right? And then it's going to be t squared, which would be x squared over y squared plus 1. I'm going to clear the fraction by multiplying top and bottom by y squared, because I'm trying to figure out what this thing is. And what would you get? You get xy on top. And what do you get on bottom? You'd get x squared plus y squared. Now, yeah, I realize I'm taking a lot of liberties here, but I'm going to say, x could be 0, by the way, but I'll just simply divide through by that. But I do know that x could be 0 just looking at that. I know y can't be 0, by the way. So what do you get over here? I know you get 1 x. I'm sorry, I'm dividing by x. What am I doing? You would get 1 equals, I'm dividing by x, by the way, y over x squared plus y squared. This still looks pretty bizarre to me. So I'm going to clear the fraction. When you get x squared plus y squared is equal to y, and you get x squared plus y squared minus y equals 0. This is definitely an equation of a circle now. How am I going to do it? I'm going to complete the square. Half of minus 1 is minus 1/2, and then a square plus a quarter. Plus a quarter. And what do you get over here? X squared plus y minus 1/2 squared equals 1/4. So this is an equation of a circle. And its center would be 0, 1/2, and its radius is also 1/2. So I'm going to put a graph down, but when I put the graph down, I'm a little careful about it. And it got 0, 1/2, and it's got a radius of 1/2. So it looks sort of like this over here. All right? So let me just talk about this, and I want to see if it makes any sense at all. Now, I know the y can't be 0, so I'm going to, it's probably overkill, but I need to remove it. I'm going to say there's circles here, because y can't be, I'm sorry, not a circle there. What am I saying there? Let me trace that in, okay? But I'm pretty comfortable with that picture now. All right, now what's your question? It says, a curve is defined parametrically. I got the curve down. And they say t could be any real number. I think I did okay. It's an equation of a circle. Determine the equation relating y and x. I did that, and that's right over here. This equation relating y and x. Right, I got that down. Sketch its graph. I did that. Then determine the minimum distance of this curve from the point. I'll write this down. This is the point over here. Now, a lot of students will say, oh, I have to do calculus now? Not really. What I'm going to do is I'm going to minimum distance would be this distance right here. Right? I need that. Now, what do I know? And I'll point this out to you. I know this distance over here is the radius. So the radius is this distance here. What's the radius going to be equal to? It's 1/2. What I want to do is I want to get the distance, though, of this whole distance here. And that's Pythagorean's theorem. So this is going to be 1/2 unit, and that's 1/2 unit. So what are you going to get? 1/2 squared plus 1/2 squared is equal to that whole distance squared. I don't know what that is, by the way. Let's put this down. That's going to be 1/4 plus 1/4. That's 2/4 1/2, right? And what's the whole distance going to be? Did I do that right? 1/4 plus 1/4? 2/4? Yeah, 1/2. Wait a second. I'm confused right now. Oh, I'm sorry. It's 1/√2. That's the distance. I'm sorry about that. I was thinking it's 1/2. I said it couldn't be 1/2. So what's that little tiny distance then? It would be, let's see, the whole distance was 1/√2. I want to get distance over here. Let me go back to black ink. So it's 1/√2, which is the whole distance here. And I got to subtract away this over here, which is take away 1/2. And what's that going to be? 2√2. And on top, what do you get? 2 minus √2. I'm going to simplify that by multiplying top and bottom by √2. And you would get 2√2 minus 2. And on bottom, you get 4. And then I'm going to divide through by 2. You get √2 minus 1/2. This is the distance. Let's see how we did. All right. And again, I'm looking at the answer. Yeah, I know I'm scrolling through this thing pretty quickly. Oh, you know what? I forgot to do number 4. I'll go back to 4 later. I got the equation of the circle, clearly a circle. And I got this thing over here. And I got a much nicer picture over here, by the way. So √2 minus 1/2. Okay, let's go back. We got one more problem to do. And let's see what we've done so far. Let me see if I wrote that down. Yeah, I wrote that down. Sorry about that. Got a very short memory. I'm going to do number 4 now. And I'm going to start to erase things over here. Again, remember, this is video that although things are erased, you can always pause these things and copy if you have to. I think it's best to listen and then try it on your own. I think the worst thing about people listening is they never get busy trying on their own. All right, they never get busy. Listening doesn't really matter too much. All right, this is tough. I'll put this one over here. And the first thing I want to do is I want to get everything in terms of sines or cosines. So I'm going to say it's probably easiest to get in terms of sines. Put this over here. 1 plus sine x greater than or equal to 2, 1 minus sine squared x. This could be a dead end what I'm doing now, by the way. All right. You can get 2 sine squared. I'm just adding that to both sides. Plus sine x minus 1 greater than or equal to 0. Let's try to factor it. Let's be hopeful. I'm going to say 1 and 1. And let's see, plus, minus. Does that work? I get 2 sine squared. That does work. And then I get plus 2 minus 1 is plus sine x. Yeah, works beautifully. Now, I want to be honest with you about this over here. This is going to be a very difficult problem, by the way. But I'm kind of assuming that it's probably not that difficult. What do I know about this over here? This is always going to be greater than or equal to 0. So this thing here is always the sine of x plus 1 is always greater than or equal to 0. That's good to know that. But it's this thing that's causing trouble for me. So I want to talk about it. And I'm going to write this down as sine x. I'm looking for its 0, by the way. Equals 1/2. And I want to remind you what your teachers probably taught you in pre-calculus, to draw the picture. I was going to draw one cycle of it, by the way. And then they told you to draw like this line. At least most teachers would tell you that. At 1/2, somewhere over here. And then there'd be 2 values here, where it equals 1/2. And what would those values be? Well, they talk about a reference triangle. And the reference triangle, reference angle, that would be 30 degrees, right? Yeah, 30 degrees, which would be pi over 6. Or it would be 150 degrees, which would be 5 pi over 6. All right? So I'm going to say x is equal to pi over 6. Let me get back to black ink. That's this one here. And this one over here is 150, which is 5 pi over 6. But what do I want? I want this thing to be greater than or equal to. Right? So I want this thing here, which is 2 sine x minus 1 to be greater than or equal to 0. Well, this is only going to happen on this interval here. By the way, when we're dealing with 0 to 2 pi. So I'm going to say the answer is going to be, on that one interval over there, would be from pi over 6 up to 5 pi over 6. But here's the problem. It keeps repeating itself. It has to repeat itself every 2 pi k. That interval repeats itself every 2 pi k. That's my solution to the problem. All right? Let's take a look, see how we did. Oh, by the way, k can be any integer. All right? You go forward or backwards. Integers. Let's see if we got it. A lot of work is down, right? Yep, we got it. All right? Same set of reasoning, too. All right, thank you for paying attention. We did all 5 problems. I want to, again, encourage you that if you see something, say something. Like if you see an error, I said something that you felt was incorrect. I do misspeak sometimes. Sometimes I say something I don't believe I said it, but I have a recording of it. I know I said it. And I make mistakes. Sometimes I look at my tape and I misspoke. I said something that wasn't true. But I hope it's not, entirely nonsense to you. But if you need to reach out to me, this is my email address. Thank you for paying attention.